All right. Well, thank you everybody for coming. And I am here from the Fire Protection Research Foundation. I'll tell you a little bit about who we are because I'm sure many of you are not familiar with us. And I'm talking about research that we've done on the fire safety challenges of tall wood buildings. Just outline of what I'm going to talk about. So I will talk about the foundation, what we do, who we are, and then I'll talk about the two different phase projects that we're doing on tall timber, fire safety. So who is the foundation? We plan, manage, and communicate research to support the NFPA mission. NFPA, if you're not aware, is the developer of a consensus-based codes and standards. We are independent, or an independent charitable organization that was formed by NFPA in 1982. The intent of forming the Research Foundation was to support the codes and standards through doing research. Where do our research funds come from? Private and public sector. So we do grant-funded projects as well as from private industry. It's basically a 50-50 split. And also other sources, including NFPA itself. Who is involved with the Research Foundation project? Well, we have our funding, our sponsors, like I just mentioned, which could be manufacturers or trade organizations, government organizations, NFPA, contractors. So the Research Foundation, what we do is facilitate research. We don't undertake a lot of research in-house unless it's very small. We don't have a test lab or anything. So what we do is facilitate it. So we do the fundraising, we do the project scoping, and communication after the fact. And we contract it out to contractors within the field, so experts out there. And that includes consultants, that includes research and test organizations, universities. And part of our process, an important part of our process, is a project technical panel, which are basically a group of subject matter experts that provide feedback on the project and provide technical oversight. So they're responsible for reviewing all the reports and deliverables. And they provide their feedback to the contractor, which really improves the end product of the research. So it's a process. Obviously, it starts somewhere. There's a need identified. There's a gap in the codes and standards, or even it doesn't have to be from the codes and standards. It could be from NFPA's advocacy or public education type projects. Anything like that touches on fire safety or electrical hazards. There's a gap or there's a data need, then we step in. We'll have a planning meeting, or sometimes we'll just start with a small project, like a literature review. What's out there? What are the gaps? Like I said, and then we form our project technical panels, which are typically made up of different groups and mostly kind of how the NFPA technical committees are made up, which include code enforcers, consultants or subject matter experts, as well as fire service members. Basically anybody that's on a technical panel type, we would include, or anybody that sits on technical committees included on technical panel. And then the research performed, the contractor does that, and then we publish the research. And everything that the Research Foundation does is published and available for free, so anybody can access that. I'm going to talk about our property insurance research group just briefly because they are one of the main sponsors for the work we're doing on tall timber. And what that research group does is it provides a place for interested members of the property insurance industries or their affiliates to discuss industry-relevant fire protection issues and to identify needs within their industries. And what this does, it provides a mechanism for the foundation for research projects that are funded, because this is their planning group as well as a sponsorship group. So we benefit each other. So we're doing research that benefits the insurers, and the insurers are sponsoring research that the foundation is doing. So they're open to any property insurance companies or affiliates. Our current member companies are listed up here. I think there are 8 now. And basically what they do is they get together and they develop, or they agree on project needs or research needs, and then prioritize those for use of their PERG funding money. So their research interests are largely around warehouse protection, but they're also interested in new hazards and building trends, and that includes tall timber buildings, which is why they are a principal sponsor for this work. So we did a phase one. Basically, we start a lot of our projects or research studies with phase one, and those are often literature reviews, gap analysis. Where do we go to fill those gaps? So a research plan or something, recommendations. In this case, it was a literature review that compiled lots of different information, actually a lot of information around tall timber buildings. It included any available test data, included specific test requirements if there are any standardized tests out there. It also compiled case studies of tall timber buildings, and since this was published at the end of 2013, I suspect there's a bunch of others that we've been hearing about here that could be added to that list. It also documented fire incidents involving timber, and then importantly, really, it was focused on buildings 6 stories and higher, so I should say that. So we really weren't dealing with mid-rise. This was focused on taller timber structures. And then importantly for us is what they did was develop some recommendations for future research. So they did an analysis of what is out there, everything out there, and what are the gaps out there. And so their recommendations were based on the gaps that they found in the technical literature. So fire testing of new and innovative timber and hybrid solutions, full-scale, large-scale fire testing of mock-up tall timber frames, natural fire testing and full-scale, large-scale tall timber frames. So this would be natural fire testing, so not a standard curve, but actual like furnishings. Economic analysis, and also emphasis on risk communication. Like Dave was saying, a lot of it's about perception. So the top 3 gaps that were identified from phase 1 for having the greatest priority for future research were contribution of exposed timber to room fires, connections between timber components and timber composite assemblies, and Dave mentioned that as well. There's a lot not known about, or there's a lot of gaps still around the connection, timber connections, and how they behave in a fire, and how that performance impacts their structural performance. And then penetrations for services. As we know, you have to feed all the services through for these mass timber. How do you fire stop that in the case that you need to, and how effective is that over time? So that report's available. The contractor was Arup, and they did the work for us. And that is on our website, and that was sponsored by the PERG. So what does that mean? So the highest priority gap from phase 1 was the contribution of exposed timber to room fires. So that's what our phase 2 research is now going to undertake. The main objective is to quantify the contribution of CLT to a compartment fire, or that was our main objective going out. And that includes looking at compartments that we'll do a fully encapsulated compartment, as well as compartments that have various other levels of encapsulation and exposed CLT. And then try to quantify how that CLT contributes to that compartment fire. So the initial project plan for this project was fire testing in CLT compartments, like I said, various levels, compared to a fire test in a steel baseline compartment to have some comparison against a non-combustible. And again, perception. It's being discussed within the panel right now whether we want to continue with that, or if we consider a CLT compartment that has 3 levels of gypsum board, enough of a non-combustible baseline. So that initial project plan may be changing due to our technical panel process. So this is underway. So this is basically a progress review. We haven't done the testing yet. A final report is expected in July of 2017. The contractors that are taking on this work are NRC Canada and SP out of Sweden. The principal sponsor groups for this is the PERG and the American Wood Council, which is through a grant from the USDA Forest Service. Thank you. The technical panel on this project includes fire protection and structural engineers. So from the design perspective, fire service members, enforcers, wood industry representatives, insurers, and then other stakeholders. So it's a very varied technical panel, a lot of different interests in this topic. So there's a lot of input from the different stakeholders. So where are we? They did a initial literature review to pull together all the available test data on compartment tests that involve CLT to really inform the actual testing that we will do. Because you can't do every single configuration. It's expensive. So trying to figure out what makes the most sense, what will have the most impact, and what's a logical next step based on what's out there. There was also some initial modeling completed to inform that test plan. And the purpose of that was really to identify the configurations for severe fires. A lot of that studied ventilation configurations, size, compartment size. They did a two-zone model, which actually did not yield very good results. So they're focused on a one-zone model that SPIA has actually developed over from another project. And that's really to estimate the charring rate. And based on the work they've done, the main assumption for that is that that the charring rate is linked to temperature and only temperature, which is interesting. Okay, so the draft test plan is being reviewed by the technical panel right now. We do expect the testing to take place this year. And there's a lot of variables actually being considered as part of the testing right now. The biggest one is the compartment size. So there's a lot of people want to make sure, we want to make sure that it's realistic, but we also want to make sure that there's a scientific basis as well, because we want to be able to quantify that contribution. So it may be hard to do that with a larger compartment. So there's going to be some middle ground here in terms of what's the best compartment size to use, and also what hasn't been tested yet. That's kind of important. Ventilation openings, what leads to a severe fire but also burns long enough to really involve that CLT, and what's realistic. And then the different structural components. We went into this really with all CLT, but we're also considering, we're talking about maybe considering some glue lam components as well. And also talking about the exterior wall and what is the best material for that. And also encapsulation details. So really, which walls are going to, so there's going to be at least one, there's going to be one where it's fully encapsulated. But then after that, there'll be some various levels of encapsulation, including maybe exposing the ceiling has been thrown out there, and also exposing some of the CLT walls or the timber walls. The compartment itself will be a studio apartment, so real furnishings are going to be used. Because we wanted a natural fire. And it will burn to flashover and to a post-flashover phase to make sure you get the longest exposure you can. So where do we go? Like I said, we're going to have compartment testing this year that's going to take place at NRC. The data collected from that testing is also going to be used to verify computer simulations for compartment fire behavior. If in fact they do validate or verify a model to be used that gives good predictions, then that could be applied to test configurations beyond what was tested. So that would be much less of a cost if you're modeling rather than, and it would be limited because it's a pretty complicated problem. We're talking about timber and burning, and there really isn't a lot of, the models can't quite get there yet, but we're trying, working on it. So by early 2017, all of the experimental test data will be analyzed and the modeling will be complete. And then, like I said, we expect the final report in July 2017, and that's going to be available to anybody. Anybody who wants to read that report is available through the Research Foundation. In terms of communication, at a minimum level, we'll be providing at the NFPA conference in 2017 in June next year, and also via a webinar, and then probably other means like conferences such as this. So future work beyond this project. We already know that we're not going to be able to test all the configurations that probably should be tested. There is more testing that should be done here and could be done. Different structural components, materials, different adhesives if you're talking about CLT. There's also other big knowledge gaps that we aren't touching with this. We're talking about connections and the penetrations were also two of the top 3 knowledge gaps that were identified from phase 1. Those are 2 things that still need to be addressed. And another thought was maybe having a workshop with the various stakeholders here. And that includes the fire service, designers, manufacturers, all these enforcers, all these different groups, and getting them together to talk about some of their concerns, and then what's out there, what still needs to be done. So really have that kind of a discussion with them. So thank you.